Is it working now? Possibly. Maybe. Yes. And we're live. Very good. Sorry about the delay. Had some technical difficulties to work through. Cool beans. So, last week, we started to actually write the code for this one. I want to open that. Open. There we go. Started to write the code for creating some of these matrices. So until we get some requests in the chat, we're going to pick up where we left off. Let's switch over to PyCharm. Very cool. All right, so last time we created this create v function, which spits out the matrix the way we expect it to be, which is in the format over here. So last time we created this one and got it doing what we want it to. This time we should be able to finish in theory. So let's start on B. So B is going to be P1 all the way down minus the rest of the vectors. Create B. So that's going to be so to create the base point vector, which is what we're trying to make here, we have to accept a list of base points. Now the question becomes, how do we pass that in? Yeah. So we'll do B points, base points. And we'll just copy and paste some code here. Who knows by 3. Okay. So it's going to come in and it's going to be a list where the first dimension, or it's going to be a NumPy array, with the first dimension being the number of sensors that we see, and the second dimension is going to be X, Y, Z. So we'll create B equals np dot zeros, where the dimension of this one is going to be len of base points by 1. And these are already in Cartesian, so we don't need to do any conversions there. So V3. Yes, I'm aware that I'm live streaming. email. Let's see. So first one is going to be base points. We want all of those. So we're gonna skip, and every third element in the B vector that we're trying to assemble is going to be set equal to the entirety of the array of B points axis to, so all of the x's basically. And then we're gonna do the same thing with this one. Hey, thanks for watching, guys. If you have any homework problems or anything that you want some help working through math-wise, just pop it in the chat and we'll get started on that. This is just time filler, basically. Two and two. All right. And so I've started this, and that's not exactly what I want it to be. Because right now I'm going to set it equal to every skip element, but I don't really want that. Is that even? Yeah. And what I want it to be is the P1 point value. Let's see if I can switch over real quick. That and that. What I want it to be is P1 here. Highlighter. Nope, laser. P1 minus all of these points. And right now what I'm doing is just ignoring all of this P1 minus stuff and just doing these points, which isn't what I want. So let's switch back over and fix it. So what I'm going to do is I'm going to repeat my point, P1. So I'm going to repeat base points, the first element. And I'm going to repeat it len base points minus 1, because we're not going to do P1 minus P1. That would just be the origin, and that's going to throw us off. And I'm going to do it along axis 0. So let's comment that out for the time being and test it. Return B. Robot measure as else. And these beacons have anchor points. So what we're going to do is change this. Nope, we're not going to change it. We're going to do def get beacon base points points equals np dot zeros len self dot beacons, because we need one for every beacon, and it's going to be 3 elements wide because there's x, y, and z. Then for I and beacon I should just copy and paste things instead of enumerate self beacons. So that enumerate is a function that I didn't really learn about till fairly recently. When you enumerate an iterable in Python, it will return to you a tuple, which is like an array but not, where the first element is an index and the second element is the element of the array, or the iterable. It's just kind of a convenient thing to be able to use. So I'm going to do points I is going to be equal to beacon dot anchor point anchor anchor. And return points. So we have create v working. We'll copy and paste and do create b instead, and we'll do robot dot get beacon base points and give that a go. Let's see if we've messed up anywhere. We have not. We have not. Let's print robot dot beacons, because I don't remember. Okay, let's print the beacon. We'll do print beacon dot anchor for beacon in robot dot beacons. So this is just for debugging purposes. This isn't actually doing anything, but it's going to iterate over the list robot dot beacons, and for every beacon in there it's going to print out the base point on a separate line, just to make it a little easier to read. So it's going to be 3, 1, 2, and this is not what I wanted it to be. Can I do that? Maybe? This may work. Nope. Put that in the wrong place. That is also not correct. I think I can just do this. Can't I? No, apparently not. So what I want it to be is 3, 1, 2, 3, 1, 2, 3, 1, 2, and it's not doing that, and I'm not sure why. Maybe tile will work instead. So I want the iterable and then repetitions. Yeah. 3, 1, 2, 3, 1. There we go. That's what I want it to be. Okay. So I've got that. Now I'm going to do the x's, which will be b, colon 3, minus that. And b, colon 3, minus. And we'll start there and there. For those who are not familiar, this colon 3 thing, that's actually syntax for start, end, and step size. And by omitting an argument, I'm basically saying start at the very beginning, end at the very end, and I'm specifying the step size, so take steps of 3. On this line, it's start with index number 1, go to the very end, and take steps of 3. The last one, start at index 2, take steps of 3. It's just a nice, convenient way to do it. And this throws an error. Could not be broadcast together. And that is because I did it wrong. Here I'm saying start at the very beginning, but I don't want to do the very beginning. I want to do starting with the second point, but the first point is 3 points long, so I need to start at index 4, and then 5, and then 6. Oh dear. All right, let's figure out what's going on. Debug. All right, so B is 312, 312, 312. B points 312, 435. Ah, that is why. That doesn't need to be. That needs to be element 1. I want all of those, all of those, all of those, and I want 1. I want to exclude the first point. 0, 1, and 2. Now it should do correctly. Yeah, okay. So 4 minus 3 is 1, negative 1. 3 minus 1 is negative 2. 5 minus 2 is negative 3. 5 minus 3. Nope. 3 minus... Wait. Something's goofy, I think. Because it should be 3 minus 4. Yeah, 3 minus 4 is negative 1. I just mental math completely wrong on camera. It's fine. 3 minus 4, negative 1. And then come to this one. 3 minus 5 is negative 2. Come to this one. And we've got 3 minus 6 is negative 3. Okay, so we're good. B has been constructed correctly. So we can minimize that one. Minimize that one. We're good to go. Now, go back to PyCharm, or to our open board, and let's take a look. So we've got this one done. We've got V done. R is going to be one of the trickier ones. Let's start working on R. I haven't seen any chat requests yet, so I think we'll just keep on moving. All right. For R, to find R, we need the formula from here. So we need this. Okay. So R equals V pseudo inverse times B. So let's go implement that. So here. All right. Too many things. It's all too big. Make it smaller. Okay, there we go. Def. Get ranges self. Now we're going to take v and b to do the thing. So r equals, first let's make the matrices. V equals self dot create v, self dot measure as else, right? And then we got b equals self dot create b, self dot get beacon base points. All stuff that we've already done. So then we just need to do r equals v. We need the pseudo inverse of v, which is numpy linear algebra pinv of v. And we need the matrix multiplication against b. Now, I happen to know that you can use this @ symbol, but if you want to do it the longhand way, we can do that too. So this is valid, but so is numpy linear algebra, not linear algebra, just matmul. And that will do the exact same thing. I prefer that notation because it's handy. And it actually works in CuPy, which is a GPU accelerated version of NumPy. Not made by the same people or anything. And it only works for NVIDIA graphics cards. But I like that library because it is fast and the interface is exactly the same as NumPy in all cases that I've tested. So then we have the ranges. So return r. And that's that. So now we'll be done with those. So we'll print robot dot get ranges. Uh-oh. Size 9 is different from size 12. What do we do? All right. Let's debug. V is 12 by 5. B is 9. Did we math wrong last time? This is going to be n minus 1 tall. 3 times n. 3 times n minus 1. N in our case is, stop. N in our case is 3 or 4? 4. We have 4 points. 4 beacons that we're looking at. So n is 4, n minus 1 is 3, so B is the correct size. V is not. Let's view that as an array. So it's 0, 1, 2. Oh, I see the problem. We've duplicated. So up here we have P1 and P1, or V1 and V1, V1 and V2, and we need to not have this column 1. And in fact, yeah, so we don't need column 1 or row 0. 1, 2, and 3. All right, let's go take a look at create V, because that's where our problem is. it's going to be len self.beacons -1. And this one is just going to be like that. Pointing vector. Enumerate pointing vec. From 1 on. Let's see if that works. Let's go back to create, or just checking create v. That looks more promising. All right. Now let's try that. Well, that looks pretty good. Let's double check it. We know where the robot is because we told it to be at 0, 0, 0. We know where the sensors are because we set them up. So now we can compare and see what are the ranges. So for beacon in robot.beacons, let's do the enumeration. Beacon in enumerate robot beacons. Print, and we're gonna get the Euclidean distance, which is just gonna be the vector norm. So we'll do beacon dot anchor minus robot dot, where's the double underscore, nope, single underscore actual position. Actual position. And this is for testing purposes, that's why there's a single underscore there. So we'll do np.linalg.norm, and that will automatically do square root of the sum of the squares. If I remember right, anyway. For all of the beacons. So what does that say? So that matches, that matches, that matches, and that matches. So it looks good in my opinion. If you're wondering why the decimal precision is different from here to here, it's because when you print a NumPy array, it does some formatting things to make it look nicer, prettier to look at. And when you print it out here, it's not going through NumPy to do that. It's just printing a float. And so it prints up to however many decimal places that is, 15, I think. So we have our ranging working correctly, which is fantastic. Yeah, that was less trouble than I expected it to be, if I'm honest. So now the only thing to do is say, okay, it's fantastic we know the ranges, but we're not particularly interested in how far away it is. We want to know where we are in relation to that. So now we've got 2 more things to do. 3 more? 3 more things to do. Let's go back to our whiteboard. So we've done V, B, we've found R, so we can draw our dotted line around that too, or draw a green line around. Green. So that's fantastic. Now we're interested in this part. The actual localization portion. And what that means we have to do is we have to find P and V locate, so that we can multiply that by R and find T, which is our positions. P is just the vector of all of the base points, which is easy enough to do. I think we can do that with a single reshape. And then V is a vertical matrix. Yeah. Right? V. Yeah, vertical matrix. Or horizontal matrix with the elements going vertically. Alright, switch back to not that, not that either. We want that one. Alright. I want to look at that. Alright. So we have get ranges. Now we want get locate V. I'm going to pass on that for a second because I think we can do the other one easier. Def get P. Create P. And we'll pass in B points. This isn't the most efficient way to code this all up, but we're getting the algorithm in place, and then we can work on efficiency later if we care. Probably we won't care on stream, and I'll fix it up for when I go to do the final thing for myself. But B points is going to be in the shape, comment, beacons by 3, which is X, Y, Z, and we want it to be in the shape 3 times beacons by none. So what we're going to do is we're going to do reshape B points dot reshape len actually will be B points dot size, because dot size returns the number of elements in that NumPy array, and that's just going to be the width times the height, so it's shorter. So let's test that. Print robot dot create P, and we'll put in robot dot get beacon base points. Three, 1, 2, 4, 3, 5, 5. I assume that's correct. Let's undo that one. 5, 5, 8. And then 6, 7, 11. Sweet! Okay, that worked perfectly. Exactly like I thought it would, hoped it would, but wasn't sure. So we'll do locate V, which is our last piece of the puzzle before we put it all together. Is it already in that format? I think it is already in that format, or very nearly. This one. Return. This one is built on as-else. Return as-else.transpose, I think. So here we'll print robot.create. Nope. And that should be create lock B. Create lock B. And we'll pass in robot.measure as-else. And that is not correct. Not even a little bit. Oh, I know why. It's because we're not in Cartesian. So we need to do spherical to cart. So self dot spherical to Cartesian as else, and the transpose of that. And print robot, and for comparison's sake, we'll do print robot, measure as else, and we're going to do robot dot spherical to Cartesian of that. Uh-oh. Yep. Okay. Yes. Sweet. So now, def locate. And what we'll do here is we'll put all our pieces together. So this is this how I want to do that? No. We're going to pass into this function v and b. This is not the correct way to do it as far as software engineering goes. This is not a software engineered thing. This is math testing. So we'll do that. As else equals that. B points equals that. As else goes here. B points goes there. R equals self dot get ranges VB, and then we will create the locate V. So we're done with V now, and I'm gonna reuse the same variable name. Please don't complain. It's okay. This is Python. We can do this. I'm gonna write over it because I don't need the old one anymore. V equals self dot create locate V off the same as else. And I'm gonna P equals self dot create P off of base points, and T, which is our final position vector. So what it's going to end up returning is a list with as many entries as there are beacons by 3 for XYZ of positions where the robot thinks it is based on the beacons. Beacons minus 1. Beacons minus 1 by 3. And that will be equal to P minus V at R. Return T. And there will be one extra step in there that I'm not doing right now, which will be to take the average along the beacon's dimension of T, because I don't need a whole list of them. But for testing purposes, we will do this. Robot.locate No! What do you mean? Alright, debug. P is 12 elements long. R is 4 elements long. V is 3 by 4. Why are these ranges not working out correctly? Or these sizes? It's never as easy as it seems. Hello? Oh yeah. There we go. Hide punch. There we go. P has n elements, which is 4 times 3. That's why. Is because V is not correct. This V locate is not correct. I did the oops. Big oops. Okay. So red line through that. Not quite. Let's fix it. So what it needs to be is T, just like we had, equals this P vector, just like we had it. P1, P2, P3, all the way through Pn. Fix that. Fix the bracket. Minus, and it's going to be like this. V1, V2, V3, Vn, 0, 0, 0, 0, 0. Like that. Times R. That's why. That way this is 12 elements tall. So our output will be 12 elements tall. Oops. My bad. So now we can fix it, now that we know what's wrong. So that means we need to fix our create locate V, which is fine. Okay, yeah. So pvex equals this. Trying to think if I can just use the identity matrix kind of shortcut thing to make that happen. Can I do import numpy as np? A equals np.uie. So that's the identity. I don't know why they spelled it like I, but whatever. 5. Okay. So if I do np.stack a axis equals 1. That's a 5 by, should not be 5 by 5. A dot D type. Nope. Dot D type. Oh, okay. Shape 5, 3, 5. That's not correct. But it might be if I do this. Reshape A dot shape 0 times 3 by A dot shape 1. That is what I'm looking for. And so if I do B equals, hang on, whoop, come back here. We'll do B equals that. C equals NP dot A range 5 by times 3 dot reshape and I want 5 elements by 3 elements. So we've got C looks like that. If I do C dot flatten, B times C dot flatten, nope. B times C dot flatten, nope. C dot flatten times B at B. No, definitely not that. This is not the mathematical way to do this. I'm just guessing and checking. What is C dot flatten? Right, exactly. Yeah. Let's see. Can I do instead B dot transpose at C dot flatten? No, not that. Times C dot flatten. Hold on. That yielded the correct results. All right, that's what we're doing then. So we will do diagonalizer equals np dot identity. That's going to be nope, pvex dot shape 0. Is that right? Yes. So we'll do that, and then diagonalizer equals np dot, what did I do? Stack. Diag, axis equals 1. And we're gonna reshape it according to pvex.shape. Nope. Diag.shape 0 times 3 by diag.shape 1. And then we're going to do our data. So pvet, nope, diag times pvex dot flatten and this is what we're going to return. And we're going to transpose this whole thing. That should be good. So then we will give this whole thing a go again. And now it doesn't like it. Why are you whining? Need the same inner dimensions. I forgot to do the transpose of this one. Try again. There we go. Sweet. Mostly sweet? Yeah. So that works for that. Now I need to reshape it and then take the average across the correct dimension. So print t, and then t equals nb dot t dot reshape and I want -1 by 3, and -1 just means automatically figure it out. Nope, I want 3 by -1. 3 by -1. And then I'm going to dot transpose it. Yes. And so it thinks I'm very, very close to 0, 0, 0, which is correct because I am at 0, 0, 0 by design. All right, so at this point we have everything in the right orientation and everything, or everything in the right shape, and so I'm just going to do t equals np dot mean for the average of t along axis equal to 0. Yes. Which should yield me something that is 1 by 3. Which is correct. Voila, we have robot localization. Maybe next time I will have some images that I will have created in Lightwave, so 3D animated images that we can use to simulate this. So I'll do a couple of colored beacons, and we can try and do blob detection, and then take those blobs, turn them into numbers that we can plug into this algorithm and have it spit out where it thinks it is. And then we can compare against our actual position based on the 3D animation, which would be kind of cool. But for now, we're almost right at the hour mark, and I don't have any suggestions in chat. I'm double checking. I have nothing. So we're going to call it here. and I'll see you guys next week. If you have enjoyed the live stream, or if it's helped you at all, if you thought it was interesting, be sure to hit that subscribe button, hit like, join the Discord. There's plenty of space in there for robotics related chat, math, homework, whatever. Pop on in there, say hello, and come back next time. We'll see you later.